Hey there, students. This is the last lecture in the series on irrational numbers geometry and volume. In this one, we're going to look at volume of solids. So this is pyramids, prisms, cones, cylinders, all that fun stuff. I'm going to start out with the previous problem because this is really what your final project or assessment is going to be. Is you're going to take a real object and then try to find the volume of it or the surface area of it. So going back to the ramp example, if I said, hey, I want to find the volume of this ramp, well, you're going to see these formulas. And basically, if it's straight up and down, it's called right, a right prism. Prism is a three-dimensional object. Or if it's an oblique, it's like tilted over. And we're going to talk a little bit more about that on the next slide. But for this one, I've got a right prism. In fact, I have a triangular prism because there's one face here that is a triangle. There's another face here that is a triangle. And basically, it's just a whole bunch of triangles all stacked together, which is the width, the width of the object. So really, what I need to do to find the volume of this ramp is it's capital BH, and capital B means the area of the base. So wait a minute, I did that in the last video. We already figured out that this side was the square root of 48, and we multiplied that by 4 and multiplied it by 1/2, and we got 13.86. So right now, I know that this one right here, I'll use my highlighter. I know you like it when I pull out special tools. Well, let's just get rolling. Come on, you're good to go. This one right here is the 13.86. So really what I'm doing is the volume then is the area of the base, 13.86, times, now the height, think of it, it's actually sideways. So my height, I'll use blue. This is what I'm going to use for my height, times this 4. And when I do that on the calculator, I went from square feet, which is area, to 3 dimensions, which is going to be cubic feet. So it's still on my calculator, times 4, and I get a volume of 55.425. So we're going to say 55.43 cubic feet. Part 1, done. Part 2, find the surface area. Okay, so surface area means the area of the sides. I've got 2 sides that are 13.86. I've got a back over here, and that appears to be a rectangle parallelogram, so that's 4 times 4, that area. I've got this front, and we'll use this one as yellow, and that's 4 by 8. And then I have the bottom, we'll go purple. I gotta say, it is kind of fun to be able to change colors like this. I gotta add that to it as well. And so that is 4 times the square root of 48, also known as 4 square roots of 48. So basically what I need to do is put all of these in my calculator, and I'm just gonna do that real quick. 2 times 13.86 plus 16 plus 4 times 8 is 32 plus, I can't do 4 square roots of 48 in my head. And again, that's 103.43 square feet. And remember, surface area is 2 dimensions, like getting paper and wrapping it over. Another way to think about it is, if you were going to figure out that you wanted to paint this ramp, you would figure out the surface area. How much paint do you need? Well, 103 square feet just to do one coat. So that would be 103.43 feet square. The previous diagram talked about what happens when you have an oblique prism or cylinder. It's kind of tilted over, or pyramid or cone. Well, actually, Cavalieri discovered this. What he said is if you took a stack of CDs, no, he actually figured this out a long time ago. This is before CDs. He was using books. He was stacking books. And he said, if you just tilt them over, have you actually changed the volume? And the answer is like, well, no, it's still the same number of CDs. It's just shifted over. Well, that actually fundamentally altered our thinking. You'll notice right here, you can see that these are the height of the object. The other thing you're going to see later on, especially in pyramids and other oblique objects that are tilted over, is you'll notice there's something called a slant height. And that's used if you're trying to find the surface area of a pyramid, right? Because you've actually got 4 triangles on the side. Oh, well, you could have many triangles. It could be a hexagonal pyramid and it has 6 triangles on the side. And if you were going to figure out the surface area of that object, you'd have to use the slant height. For now, we're not going to go any further in that. Where we are going to go further is, how do you find the volume of a pyramid? So again, some mathematician a long time ago said, wait a minute, let's just take a cube, a box, or whatever, and let's break it down in to pyramids, and said, okay, if they all come together at this point right here, basically, we can pull out 3 pyramids from 1 cube. And you'd say to yourself, well, wait a minute, a cube is just side times side times side, or side cubed, right? Well, really, what you're saying here is it's just 1/3 of that. The pyramid is just 1/3 of the entire prism. And that's a really cool thing. I can kind of break this down here for you. And we're like, all right, there's 1, 2, 3. So like that is one. Oh, sorry, wrong side, general. Like that is one of the pyramids right there. The second one, we'll do the green, you know, boom, boom, boom. You have to have 4, right? Boom. I mean, it's just crazy. This is really, and of course the last one is over here on the side too. You just go, you know, boom, 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 and then there it is in the back. And that's what they're trying to show you in this diagram. If you stare at it too long, you're going to go nuts. The big thing to remember is pyramids and cones are 1/3 of the volume of prisms or cylinders. And again, a cylinder, I kind of probably just glossed over this before, but it's the volume of a cylinder is area of the base times the height, or pi r squared, because it's a circle, times the height. So continuing where we left off there, if it says find the volume of a pyramid, again, you'd be saying, all right, the volume of a pyramid is equal to 1/3 the area of the base times the height. The area of the base in this case would be 5 times 3. It's a rectangle, so this would be called a rectangular pyramid. And then you'd multiply that by 7. So that would be 15 times 7 divided by 3, 15 times 7 divided by 3, or 35 cubic inches. You can see that you can actually cancel some things out. You're like, oh, 3 divided by 3 is 1. That's where you're 35. I'm not going to worry about the other example. You can do it. Let's do a cone, and it says give your answers in both terms of pi and rounded to the nearest 10th. This is pretty important too, because you should really do one and then just get the other. So in this one here, area of a cone is equal to 1/3 pi r squared times the height. Sorry, 1/3 height pi r squared. You'd have 1/3 times 12 times pi times 4 squared. So 1/3 of 12 is 4. So you've got 4 times 4 is 16. And 16 times 4 is 64. So this is 64 pi units feet cubed. That's the exact answer. There's no rounding. Now what I would do is just do 64 times pi. There's always a pi button on a scientific calculator, and you get 201.061. So that would be roughly 201.06 feet cubed. So actually that's a much larger thing. That's a lot of space inside there. The last thing we're going to talk about here in this lecture, and I realize I ramble, I'm sorry, maybe someday I'll get it, is a sphere. I mean, the fact of the matter is, Earth is not a perfect sphere, but it's pretty close. It's got a little extra weight around the belly. You've been on a spherical rock your entire lives. Might not feel like it, but you've actually been on a sphere. And again, the center of a sphere, what is a sphere? A sphere are all the points equal distant to a point, which is kind of cool because that's actually a three-dimensional definition. A circle are all the points equal distant to a point in a plane, but a sphere is in any direction. Okay, and again, that radius reaches out to the edge. Each half of a sphere is called a hemisphere. There's a great circle, you know, the circumference equals 2 pi r, which is also the diameter times pi, right? Easy kind of ways to do things. I'm not going to go into the details of where these formulas come from. You'll spend time on that in the future. But when you think about the volume of a sphere, the formula is 4/3 pi r cubed. When you want to find the surface area, capital S, it's 4 pi r squared. And so let's just do two examples, find each measurement, give your answer in terms of pi. Let's do the volume and surface area just to practice both. So the volume, 4/3 pi r cubed. Wait a minute, r is 5. 5 cubed, 4/3. 5 cubed is 125. So this would be 4/3 pi times 125. If there's anything you could simplify in the fraction, do that first. If not, 125 times 4 is 500. So this would be 500/3 pi millimeters cubed. And again, I could put that in my calculator. So 500 divided by 3 times pi is 523. Actually, it's going to round up 523.60. And let's just do surface area while we're here. So you have an example. Capital S equals 4 pi r squared. And here again, that's going to be 4 pi 5 squared. That's going to be 4 pi 25. That's going to be 100 pi millimeters square, which is roughly, and again, I'll do that on my calculator, 100 pi 314.16. I hope these examples help you. There's a lot, and actually what you're going to do is do this for real. This other problem here with the diameter, basically in order to plug that into your formulas, you just cut 16 in half and you'd have 8, and then you'd do the same thing. Hope this was helpful, hope it was interesting, and hope it gives you a good insight into what's to come. And I'm sure this is going to be helpful in your performance assessment on volume.